Hi, and welcome back to Geology. This is Miss Sparks, and today we are going to talk about volcanoes that are a part of our subduction area, which is found in our convergent boundary. And so we're going to go through and kind of talk about some of the significance of them, the different types of volcanoes, the different types of eruptions due to what types of rock and sediment might be there. So think back just a little bit to when we talked about igneous rocks and how with our igneous rocks you could have either intrusive or extrusive, which has to then deal with what type of magma is going to be present with what type of minerals. So going back to Bowen's reaction series, when you have mafic, heavy, dark minerals, and then you have felsic, more lighter colored minerals. So some of these tools that we talked about and learned about in our igneous chapter is going to kind of come back into play as we talk about these different types of volcanoes. So once again, a volcano is going to normally be found in one or the other type of boundary, either a convergent boundary or a divergent boundary. The more significant ones are going to be found in our convergent boundary, and then we do have some anomalies where we can have a hot spot, which is also going to create a volcano, and we'll talk about that with Hawaii and actually Yellowstone as well as an example of a hot spot. So do grab a sheet of paper and a pencil and take some notes on volcanoes. So the first thing we're going to discuss is what is a volcano exactly. So let me pull up. Oops, went too far there. So once again, a volcano is just going to be an area where gas and pressure is being pushed out of the Earth's crust. So it is areas of the Earth's surface through which magma and volcanic gases are passed through. And that can either be due to a force that is being caused by subduction, or an area where magma is just going to be pushed up in some type of plume. So normally we're talking about our intrusive magma chambers that are going to be erupting out on the surface. The word volcano comes from the Roman term Vulcan, which just means fire. And if you've ever seen a volcano erupt, we can definitely agree that it is very furious fire, kind of depending on it. We'll look at a couple of different eruptions. Clearly you don't want to be by any magma ever. It would be very, very hot, as well as very stinky. It actually smells pretty bad like sulfur, and we'll talk about why that is. So when we're looking at volcanoes, let me just pull up everything here. There's a couple of different things that we're going to discuss. The first is just that you have the actual body of a volcano, and some of these terms might sound a little bit familiar, such as our sill or our vent and dike, which is all different types of igneous, intrusive categories that we have discussed. And so all of these can be found within a volcano depending on what kind of magma source it is being brought to it. So some volcanoes have huge magma plumes that are being piped up from a subduction area. Some are just a magma chamber that is trapped, or just a chamber that is always exposed over and over and over again. So that molten rock is going to what feeds the volcano. Once this molten rock is gone, the volcano is no longer in existence, and it is called either an extinct volcano or sometimes a dead volcano. And there are several of them in the area or on the world, but the ones that we're going to mostly talk about today are ones that have been active more recently. Vents are also a part of a volcano, which normally is going to kind of like let out some of the heat so that it doesn't become so explosive. So you'll see that there are a lot of times areas that are going to vent out these gases. Oh, I have music that goes with my PowerPoint. So there's different types of magma, depending on what type of minerals are present in that magma, or what types of minerals have melted from the rock that now make up that magma. The first one we're going to talk about is basaltic, which is surprisingly made of basalt. So this is our heavier elements, very, very, very rich in density. It contains small quantities of water and low amounts of silica and other gases. This is a type of eruption that is normally pretty quiet on the front. Hawaii is a great example of basaltic eruptions, that it is taking from the bottom of the ocean floor, that basaltic rock, and bringing it up and erupting it back out. It does contain a lot of iron, and once again, it's not one of our more explosive volcanoes. These are normally ones that are probably found on our divergent boundary, and then some on hot spots. Some hot spots can be very eruptive and some not so much, just depending on what is the surface that is like lying over top of it. Hence the term, if you could hear that music there. The other type of magma that we can have is granitic, which has a lot of carbon in it. So this is magma that is mostly melted from granite, more felsic type minerals. It contains high amounts of water, high amounts of silica and other gases, which makes this highly viscous. And you might remember that term from when we talked about igneous rocks too, is that viscosity means like the resistance of flow. So this granitic rock, or this granitic magma, is very, very sticky, and it kind of picks up a whole bunch of other stuff as it tries to move through that neck of the volcano. And this granitic magma is normally extremely explosive due to that high amount of silica and the other gases, which is normally going to be carbon and methane, other type of greenhouse gases. So granitic eruptions are very, very, very explosive. This would be your Mount St. Helens or your Mount Vesuvius, Mount Etna. These eruptions are just, and they kind of blow off the top of the volcano, sort of. So there's a couple of different types of volcanoes we're going to talk about. So we're going to discuss 3 of them. The first one is called a shield volcano, and this is going to hold more to our basaltic type of eruption. It's built in what we call layers and not very explosive, but is very, very steep. And so you're probably like, what is this picture she has here? If you can see in the background, this is Kilauea, which is one of the Hawaiian islands. And so the Hawaiian Islands is a great example of what we call shield volcanoes. They are very, very gently sloped, and they're really, really, really huge. You got to think this structure starts at the bottom of the ocean and just slowly comes up over time because it just keeps erupting, and that layer solidifies and cools, makes a new, erupts again, solidifies, and makes, so every eruption makes it bigger and more gently sloped, if you kind of want to think about it that way. Can't talk about Hawaii without not understanding a hot spot, and that is exactly what is happening there. So a hot spot is an area of weak material of the lithosphere, but the asthenosphere is exposed. Hot spots are actually stationary. It is the plate that is moving, and so that's what we get. That's why we get the chain of islands. So the Hawaii is a great example of a chain of islands, is that a new island comes up, plate moves, boom, new island comes up, boom, plate moves. So the plate is always moving and taking with it a island, and then the active volcano is always what is over top of that hot spot, and that's what this is saying. A shield volcanoes form above hot spots buried in the mantle. Hawaii is a great example of this. The Pacific plate keeps moving, it keeps getting pushed, and as that happens, a new volcano comes up, it pushes again, a new volcano comes up, it gets pushed again. So here's a great picture of a time lapse of what Hawaii looks like. So older volcanoes will erode back down, and our new volcano will be the largest and most active. And so right now, if we look, this Hawaii is called the Big Island because it's forming right now, but Maui, Molokai, Oahu, and Kauai are all islands that are slowly eroding down. Even if we were to dive down past Kauai and look underneath the ocean, there would still be some other chains of islands which are called seamounts. It's just that they've moved now below sea level. Just to give you a picture of some of our Hawaiian island volcanoes, is once again that magma is very basaltic. It has a lot of water in it, so it's a little bit more runny. And so here is one of the craters there. You can see the magma running into a field. It will solidify and just create new rock, and then hopefully vegetation will overtake it at some point. It does run right into the oceans too. Once again, no one is fearful of one of the islands erupting to a point where it would cause harm. It would just be that the lava might overtake a community, and that would be devastating. But it's not like someone is scared to live on the island because of that eruption. I'm going to stop here. We'll pick up with part 2, talking about our other different types of volcanoes. So hopefully this was helpful.